Hi guys, good to see all of you. Today we're going to learn a new topic about solving systems by substitution. A couple of quick reminders, don't forget to email me if you have questions, and then make sure you check your email right away. I'm noticing people will email me and then they'll wait 2 or 3 days and then I never hear from them and then their issue's never resolved. So I'll get back to you mostly that same day, especially if it's during the week. It's definitely not too late to turn in late work. You don't have to ask me if you could do late work. Just start doing whatever e-learning you haven't done, get it going. Make sure to set yourself up for success. Have out your pencil and paper and be ready to take notes and try the try problems as we go. Make sure you're using your school email address. You will not be able to submit if you do not have your school email logged in. There's never a reason right now to guess, leave blanks, or write IDK in an answer blank. These are not tests. Email me or attend office hours to get your questions answered. Better yet, go back and rewatch the video for the parts that you're not understanding. Don't forget about remediation at the end of the semester. To be eligible for remediation, you have to have a 60%. I know this transition to e-learning has been difficult and your grades are not where you want them to be, but most of you, it's just because of your missing assignments. Just do your work. We'll get you to pass. I'll help you if you have a 60%. We can get this together. Thank you to everyone who's putting in time to watch the videos. Make sure you're watching the review video and the new material video. Today's email etiquette. Last time we learned about the difference between the subject and the body of an email. The subject should just be a couple of short words in the subject line, and then the rest should be sentences in the body of the email. One thing to keep in mind is that it's important to be respectful when sending requests or questions to your teacher. I'm even careful about this myself when I ask Ms. Dorsey or Mr. Harper for something. Using phrases like ASAP or why haven't you updated my grade are not the best approach. I'm working super hard to update grades, answer emails, create video lessons. So just like be polite, ask me for what you need. Bonus opportunity. This week, send me an email with an appropriate subject line, correct grammar and punctuation, and a polite greeting and closing. This can be a question about an assignment or office hours, or just a note to say hello, and I'll throw you some extra bonus points your way in the gradebook. Let's start with some review. It says write an equation. I noticed that last time when it said write an equation, some of you did this. You did 6 minus negative 4 all over 4 minus negative 2. Or you could have written it as negative 4 minus 6 all over negative 2 minus 4. These will give you the same answer. So this became negative 4 minus 6, which is negative 10, negative 2 minus 4, which is negative 6. A negative divided by a negative becomes a positive, and then both of these are even numbers, so they can be divided by 2. 10 divided by 2 is 5, 6 divided by 2 is 3, and then you stopped and you said that was it. This is a problem with us not reading directions. The question does not ask you for the slope, it asks you for the equation. You need the slope, yes, but you're not done here. You also need to think about your vocab words. We have points and we have slopes, so we need to use point-slope form. Point-slope form is the one that looks like this. Y minus y1 equals m times x minus x1. So we are choosing either one of these points. It doesn't matter which one. So you can do y minus 6 equals 5/3 times x minus 4. That is an equation and we are done. It does not say I have to turn it into slope-intercept, so it's okay to stop here. If it said slope-intercept, then we would want to distribute and then add 6 to both sides, but it doesn't say we have to do that. You try this one on your own. Notice that it says write an equation, so you're not just finding the slope, although you do need to find the slope first. Go ahead and pause the video and try this one on your own. Welcome back. You should have subtracted the y values on the top, so it should have been 8 minus negative 4 all over negative 3 minus 3, which is not 0. Remember, keep, change, change. 8 plus 4 becomes 12. Negative 3 minus 3, I don't do keep, change, change. The minus and the negative aren't right next to each other. Negative 3 minus 3 is like if I borrowed $3 and I borrow $3 more, I owe you $6. Positive divided by a negative is a negative. 12 divided by 6 is 2, so your slope is negative 2 here. Again, you're not done. We have points and we have slopes, so we need to use point-slope form, which is y minus y1 equals m times x minus x1. You might want to write this down in your notes if you haven't written it down recently, that this is point-slope form. And then you always substitute into the same blanks. So this becomes, I'm going to use the first point. It doesn't matter which one you use. Y minus -4 equals -2 times x minus 3. Or you could have done it as y minus 8 equals -2 times x minus -3. And again, this does not say slope-intercept, so you can stop there. It just says write an equation, and we did. All right, standard form. Remember, standard form has the x and the y on the same side of the equal sign. A has to be positive, and A, B, and C have to be integers, no fractions or decimals. So if I want to put this into standard form, I'm going to start by multiplying every term by 3 to get rid of the fraction. You see if you can pause the video and try to finish it from here. Welcome back. You should have simplified this. 3 divided by 3 becomes 1, 1 times 2 becomes 2, and 3 times 5 is 15, which I almost wrote there on accident, so this should have been 15 here. We're going to subtract 2x from each side. So we get -2x plus 3y equals 15. And I want you to think about why this is not yet in standard form. We are not done. What we need to do is divide everything by -1 because remember, a has to be positive. So this becomes 2x minus 3y equals -15, and we're done. We have the x and the y on the same side. A is positive, and we don't have any fractions or decimals. All right, now you pause the video and try this one on your own. Remember, slope-intercept form is y equals mx plus b. If you haven't written that for a while, you might want to write that down in your notes now and then go ahead and try this problem. Welcome back. You should have subtracted 5x from each side because on slope-intercept form, we are isolating y. That leaves me with -4y equals -5x plus 16. And then again, to continue isolating, to divide everything by -4. The -4's cancel. And then be careful here, this is going to create a fraction. We have the large number on top and the small number on the bottom, and that's okay. And the negative divided by the negative becomes a positive. And both of these get divided. 16 divided by -4 is -4, so you could have written it like this, or you could have written it like this. Either answer is correct there. All right, solving systems by substitution. Systems are used when we need to solve for 2 variables instead of just one. So let's say I need to know what x is equal to and what y is equal to. If I just have one equation, that's not enough information. X and y could be a lot of things. Remember, these stand for some kind of line, which has an infinite number of points. All of these have different x's and y's, and all of them are correct. But if I have a second line that maybe crosses through that one, then I can identify a point that works for both. So if I have 2 variables, I need 2 equations. 2 variables, I've got an x and a y. To figure out what the x and the y are, I need to have 2 equations. To solve a system, we're going to find both x and y, and our answer will be an ordered pair. What we're actually finding when we solve a system is we are finding where the lines intersect. So let's try graphing these. Let's start with our first one. It's already in slope-intercept form, which makes it pretty easy for me to graph. My y-intercept, which is my starting point, is 1, so I'm going to put a dot where y is 1. My slope is 1/2. Remember, that's my rise and my run, so that tells me to go up 1 and over 2. And I'm going to do that several times because I want to find all of the whole numbered points that are on the line. Remember, I can go the other way. I can go the opposite. If I went up and to the right, now I can go down and to the left. Down and to the left, down and to the left. So that is one line. Now let's find the other one. For this one, the y-intercept is not 2, it's -2. So there's my y-intercept, the beginning point. The slope is 2, and remember 2 as a fraction is 2 over 1. So we're going to go up 2 and to the right 1. Up 2 and to the right 1. And I'm going to stop there because what I have just found is the point where the 2 lines come together. See if you can pause the video and think about what the solution is to these 2 equations. You should have said that your solution was 2, 2. Your x is 2 and your y is 2 because the spot where these 2 lines come together is at the point 2, 2. All right, let's try to graph these together. Right now, I want you to pause the video and I want you to identify your slope and your y-intercept for each one of these. Let's go ahead and do that now. For this one, you should have said that your y-intercept was -3 and that your slope was 4/3. For this one, you should have said that your y-intercept was +3 and your slope is -2/3. So let's graph the first one. The y-intercept is -3, so I start at 0 and go down 1, 2, 3. And then the slope tells me to go up 4 and to the right 3. Up 4 and to the right 3. And then if I could go down 4, oh, that doesn't leave me enough room. So those are the only 3 points that are going to fit on my graph here for that first line. Sorry, my line's not very straight there. For the second one, you should have used a y-intercept of +3, and this time I want you to be careful. Remember, you can treat this as -2/3 or 2/-3, but you cannot treat this as -2/-3. There are not two negatives there, there's only one. So you can either go down 2 and to the right 3, which is right here, or you could go up 2 and to the left 3. In any case, your intersection point is right there. So I made this kind of messy, sorry about that. If you can't see that, that's the point that is over 3, that's your x value, and up 1, that's your y value. Sorry, I wrote that weird. 3, 1 there, your x and your y. All right, here's the problem. We cannot always use a graph to solve a system. I want you to pause the video now and see if you can find the reason that the following equations might be hard to graph. All right, so let's look at each one of these. For this one, it has a y-intercept of 5, but my slope is 3.75. I don't know how to do a rise and a run with a decimal. So this one would be difficult to graph because my slope is not in fraction or whole numbered form. For this one, my numbers don't even fit on the graph. These numbers are way too large for me to find a y-intercept of 1,000 and a slope of 250. I don't want to count up 250 and over 1. For this one, it's not in slope-intercept form. It's not going to be easy for me to graph because these numbers are going to turn into fractions and decimals. It's in standard form, so I don't even know what the slope and the y-intercept are without doing some algebraic work. So the rest of what we're going to be learning today is about how do we solve a system? How do we find where the lines intersect at the x and the y if I don't want to graph every time, if I want to do something different? So let's go ahead and stop here, and you can go back to Haiku and open up the video, and we'll go to part 2 of the lesson for today.